M Machine. Purpose. The M Machine demonstrates integer multiplication using similar triangles and their proportional parts. Construction. Enter line y equals 1 and at point A on the x-axis. Construct a perpendicular line from point A to line y equals 1 and label the intersection point B. Now construct a line through the origin 0, 0 and point B and add line y equals x. Also add a point C on the x-axis and construct a line through point C parallel to the y-axis. Label the intersection point D of the vertical line and the line y equals x. And construct a line through point D that is parallel to the x-axis. Label the new intersection point E and construct a perpendicular line from point E to the x-axis and label the intersection point F. Draw segment DE and plot point G at the origin. Now draw triangle ABG and triangle FEG. Proof. Case number 1, x-coordinate of point C is greater than 0. That means that point C is always on the right side of the y-axis, and it is also positive. If this is the case, then triangle ABG and triangle FEG will have point G in common, and both triangles will have right angles, A and right angles F. If point A goes to the other side of the y-axis, point C is still greater than 0, we still have triangles BAG and triangles FEG sharing angle G and also with right angles A and F. Therefore, triangle ABG and triangle FEG are similar triangles by angle-angle similarity. Case number 2. The x value of point C is less than 0. This means that C is now on the left side of the y-axis, and the triangles are no longer sharing an angle. In this case, triangle ABG and triangle FEG both have right angles A and F, but instead this time segment BE and segment FA are intersecting segments that form congruent vertical angles BGA and EGF. Therefore, triangles ABG and triangle FEG are similar triangles by angle-angle similarity once again. Since segment DC and segment EF are parallel, and segment DE and segment CF are also parallel, we have CDEF is a parallelogram, and therefore the opposite sides DC and EF are congruent. The length of segment BA is equal to 1 because segment BA is a segment from the x-axis to the line y equals 1. Since the triangles are similar, they will have proportional sides. We have the proportion GA over GF equal to BA over EF. This means that using substitution, we have segment GA over GF equal to 1 over DC. And finally, we obtain, by cross multiplication, that GA times DC is equal to EF. In other words, the x-coordinate of A times the x-coordinate of C will equal to the x-coordinate of F. Two times 3 equals 6. Now if we move point C, we get 2 times negative 1 is equal to negative 2. 2 times negative 3 is equal to negative 6. 3 times negative 3 is equal to negative 9. Or 2 times 3 equals 6. We also have negative 2 times positive 3 equals negative 6. And this is showing us the M machine displaying integer multiplication by the use of similar triangles.